5.5, properties of logs. Again, in Math 3, you looked at pretty much every property that is here except for maybe property 1. As I'm going through the notes today, I'll be scrolling back and forth showing you which property I'm using. It'll make this take a little bit longer, but it is going to make this a lot easier. So we do have several properties to use with logarithms, which allow us to expand a log so it's easier for me maybe to solve, or to condense a log. So instead of having 2 or 3 logs being added or subtracted, I will only have 1, which may make it easier for me. So properties to keep in mind. The first 2 are when things cancel. These are our identity properties. When I have bases that are always the same, they're out of here. And you're just left with whatever that exponent is in property 2. Or here, you're left with what you're taking the log of. So it makes it very, very nice to memorize these properties, or maybe just don't forget to keep looking back at them. Properties 3, 4, and 5 are probably the most used properties. So property 3 is the product property of logarithms. If you have something like a 2x, well, that's 2 times x, and you could separate it into addition. Or if you have a 2 over x, you can separate that into subtraction. Or if you have an exponent, you can move the exponent to the front of your log, so now you're not having to deal with that. So for each of these properties, this is the general property, and then I'm giving you an example of each property in use. And then we have 4 more properties over here. Number 6, well, all of these ones are used when we're solving logs. If I have a log equals a log and they have the exact same base, which is the a here, you can cancel them. They're gone. So log of 3 equals a log of 3, they are out of here. But if I have a log of 3 something plus a log of 3 something equals a log of 3 something, you cannot cancel. It must be a log equals a log. So you would have to condense this first. So be careful with that. Don't jump the gun on wanting to just get cancel happy and trying to make everything easier for you. All right, now the next one is pretty much the same idea again, that you guys can cancel the logs, but it's kind of the inverse of property 6. You could log both sides if you don't have a log there. Maybe it might make solving easier. Whatever you guys want to, or when you guys are working through these, it's whatever you see that needs to be done. You're going to have to know when to use which property. 8 is our change of base formula, so we could use the common log in our calculator. Also with your calculator, do not jump the gun on solving with a calculator. You will not be able to do that with most of these logs. You're going to have to use the properties. You cannot use a calculator unless you have a log base 10. This is the only time that you can use a calculator. So please be careful. Please, please, please. And then number 9 is really just showing you that log and natural log are essentially the same thing. They do represent different values, but their properties work the same way. So let's practice using these properties, and let's see if we can get this video shorter than that last one that was 27 minutes. So find the exact value, no calculator. See how your base is not 10. You can't use a calculator. So how do we do this without one? Well, I see addition. And if I come back up here, property 3 goes from multiplication to addition. So if I have addition, I could go backwards to multiplication. So log of 6, and then this becomes 9 times 4. Log base 6 of 9 times 4. So 9 times 4 is 36. Now there's two ways you can do this. You can set this equal to a variable and you can say 6 to the x equals 36. Use mental math. X is 2. Or you may decide that you don't want to rewrite it into exponential form. And you may say, oh, 36 is 6 squared. So I can rewrite this as the log base 6 of 6 squared. Then I can use one of the identities, which will cancel that. And what are you left with? 2. So you take your pick how you want to see that and go through and solve it. B. Oh, this is nice. I see E and LN. And every time you see an E with an LN together, they cancel. And here I'm left with 7. C is using the property that I just talked about in A. When you see that these are the same, they cancel and you're left with the exponent. I'm left with the exponent because of the power property. So let me show you what's actually taking place here. If I move the 3 in the front, I have 3. Log base 6 of 6. Well, the log base 6 of 6 is 1. So this is 3 times 1, which is 3. So that's how we get the 3. But if we're looking for that repeated reasoning and that regularity within our work, then yes, I can just recognize that the log base 6 of 6 is going to cancel and give me 1, and I'm left with 3. And then here I see subtraction. Because I see subtraction, I know that that becomes division. If I look back here, property 4, fraction, subtraction, those go together. I remember that one because of the rhyming, fraction, subtraction. So subtraction will become 12 over 3. It becomes division. And what is 12 divided by 3? 4. And this cancels. Now, it's not 0. What is the exponent on the 4? A 1. So I am left with 1. These are easy, but you have to keep looking at your properties. This is not something I expect you to memorize. We will put them on your foldable. It will make your life easier if you keep looking back at them. Don't just be like, oh, I got this, I know this, and then you make a mistake. Okay? Take the time to look back. Now, example 2 is always a struggle. You are told the natural log of 2 is going to equal A, and the natural log of 3 is going to equal B. And it says we want to write each of these logs in terms of A and B. So I want to get rid of the natural log, but I can't E because this is just an expression. It's not an equation. So I can't E one side and not the other. There is no sides here. So I have to think about how can I rewrite 8? Well, 8 is 2 times 4, and then 4 is 2 times 2. And that works out great because I know the natural log of 2 is A. So this is the natural log of 2 times 2 times 2. Well, what does multiplication become? Property 3, I believe it is, says multiplication becomes addition. So I need to separate these. So this is the natural log of 2 plus the natural log of 2 plus the natural log of 2, which is A plus A plus A. I'm getting that from right there in case you're lost. And A plus A plus A is 3A. Now I'm going to move on to B, where it's the natural log of 0.5. Well, I don't know the natural log of 0.5, so I am going to turn the 0.5 into a fraction. Now this is going to get me somewhere. Property 4, division becomes subtraction. So this is the natural log of 1 minus the natural log of 2. Oh, the natural log of 2 I know is A, but I need to work with this natural log of 1. Well, 1's a special number, and 1 can be made from anything. So I'm going to use 2. 1 is 2 over 2. So this is the natural log of 2 over 2. Well, now we need to remember from property 4 that when I see division, it is going to become subtraction. So this is the natural log of 2 minus the natural log of 2. And then I bring down this other one, which was minus the natural log of 2. And what was natural log of 2? A. So this is A minus A minus A. Well, A minus A, that cancels, and I'm left with negative A. And in C, again, I see a fraction. Fraction becomes division, property 4. Natural log of 3 minus the natural log of 2. It is important that you remember to put the numerator first. And if I look back here, the natural log of 3 is B. And the natural log of 2 was A. And since I can't simplify B minus A any further, it's going to stay B minus A. Questions, make sure you're writing them down. Example 3, write each expression as a sum and or difference of logarithms. Express powers as factors. Expressing powers as factors, that means if I have an exponent, I need to move it to the front using the power property, which is property 5, I think. So let's see here. X over 25. This is going to become subtraction. So this is the log base 5 of x minus the log base 5 of 25. Now the log base 5 of x, you can't do anything else with that. But the log base 5 of 25, you can. And you do need to recognize that you can. If you don't, I will not give you full credit on a quiz, and on a test, you will not get any credit. So please make sure that we remember that we can simplify the log base 5 of 25. 25 is 5 squared. So this is log base 5 of x minus log base 5 of 5 squared. Now I can use the identity and the power property, where I can move this 2 to the front. The log base 5 of 5 cancels, and I'm left with the log base 5 of x minus 2. Be careful with that 2. The 2 doesn't go into the front of the very first log. It goes in front of the log that it is attached to. Be careful with that. All right, B. Well, let's see here. It's not x times anything, but it is x to the 4th. So we are going to have to use the power property here. So my exponent's going to go to the front. So this is 4 log base 6 of x. So I've taken care of the last set of the directions where it says express powers as factors. I did that. It's 4 times the log. But the beginning part of the direction says write each expression as a sum and or difference, which means addition or subtraction. And I don't have that here. So I need to think of this as, like if I had a 4x, well, that could be x plus 3x. That could be 2x plus 2x. It could be 5x minus x. So there's endless possibilities here. I'm going to just make this easy. 2 log base 6 of x plus 2 log base 6 of x. And if I were to add those back together, it would give me 4. And you could do 1 and 3. You could do 5 minus 1. You could do 6 minus 2. Any way you guys wanted to work that one. Now let's look at C. 16 times y. Oh, that's the product property, which means this is going to become addition. So log base 4 of 16 plus log base 4 of y. Now the log base 4 of y is done because that's a variable. But the 16, we need to remember that we can simplify that. And I know this because my base of the log is 4. If my base of the log was 3, then there would be nothing else I could do. But I can rewrite 16 using a 4, and that's 4 squared. The log base 4 of 4 cancels. I'm left with the exponent of 2 plus log base 4 of y. This is going to take an awareness of paying attention to what you're given and the properties that you have and how you can use them. You have to pay attention to make sure you have completely simplified all of these. It's a given that you will simplify, not, I don't feel like simplifying, so I'm not going to, and it didn't ask me to. It doesn't have to ask you to. Simplifying needs to be just an actual part of what you are supposed to do. All right, last example, write as a single log. So now we're going to go the opposite direction of what we just did. What we just did was take a single log and we wrote it as multiple logs. Now we're going to take multiple logs and write it as one log. Before I do this example, I'm going to come over here to this one in green and hope that it will help make more sense to you. First, I see a number in front. So that has to become an exponent. So we're working backwards. So this is log base 3 of x squared minus log base 3 of 4. Now, once I see that I have subtraction, I need to immediately be thinking division. So log base 3, the numerator goes, the front number is your numerator, so x squared over 4. And there's nothing you could do to simplify that any further. I have rewritten from 2 logs to 1, and I am finished. So let's apply that over here. I see a number in front. Numbers in front used to be exponents, so I'm going to start by moving those back. And I leave them outside of the parentheses. Now here's the tricky part. Those exponents of 1/3 and 1/2, they're not okay left like that. If it was 3 and 2, sure. The fractions, no, those are rational exponents. And rational exponents can be rewritten as radicals. On a quiz, would I mark you wrong for that? Probably not completely wrong, maybe take off a little bit. But on a test, you would just have to look at the choices available to you. If they're leaving them as exponents, fine. If they're not leaving them as exponents, then you need to think about what can I do to get rid of them. So a 1/3 actually used to be a cube root. So this would be x cubed plus 1 inside of a cube root. And a 1/2 used to be a square root. And there's nothing I could do to simplify those. The last thing I can do is I see I have addition. So I can rewrite this, or have to rewrite this, as multiplication. So I have the cube root of x cubed plus 1 times the square root of x squared plus 1. And here I have gone from 2 logs to 1. I don't have my exponents anymore. They have become roots, and I'm finished. Again, it might be a possibility for you to leave them as fractional exponents, but you still would have to change this into multiplication. So you would still have the 1/2 and the 1/3, and that would be done. This is the way I would really like to see it, though. And lastly, just so you are prepared for your work, for 65 and 66, it's asking you to use the common log formula or the change of base formula. So change of base formula. When I look at, and it says to use it to evaluate the log, and you do get to use a calculator, I cannot rewrite 7 with a 3. But I can't use a calculator yet either, because the calculator is only for base 10. And you should remember that from Math 3 last year. So how do I rewrite this so I am able to use my calculator? The change of base formula becomes the log of 7, that's the main part of your log, over the log of your base. Now you can use your calculator. When I don't have a base, a log is the same as log base 10. It's an invisible 10 there. My students from last year, you better remember that. Now you can use your calculator. Please be careful. When you hit log, if parentheses come up, close the parentheses and then divide by the log of 3. When you hit log, if parentheses do not come up, you can just plug in as is. And I don't have my calculator with me, so I'm not going to figure that out, but when you're practicing the ones in your book and you're checking your answers and you got it, then you're good. If you have any questions, write them down, or you should have already written them down as we were going through this. You need to watch it again, go ahead. If not, I will see you in class tomorrow.